Hey guys, welcome back for our second session. It is with Kumar Aniruddha. He's one of our co-founders at Blockchain India and co-founder at Acyclic Labs. Today we'll be talking about developing applications on Tangle. Over to you, Aniruddha.
Thanks, Manav. Hey guys, I hope you guys can see my screen. So we obviously don't have enough time to go through a hands-on session, but we'll try to cover as much as possible for you guys to for all the developers out there that you can start developing on Tangle, and if needed, then we can have a follow-up thing after that. So a little bit about a little bit about me first. So yeah, we I think you guys heard about what Blockchain India does. For me, I'm primarily a developer, platform architect. At Acyclic Labs, we work on blockchain and Tangle-based applications, mostly Ethereum and IOTA Tangle-based. In the fintech sector, supply chain sector, and documents and certification sector, and so on. Um, so today, what we'll be covering is a basic primer of what IOTA Tangle is. How can you connect to a Tangle node? What are these nodes? Basically, what are the components that you require? How can you start building? And a little bit about how you can, just a primer on building on that. And we'll go through a few case studies, architecture side, so you guys can, follow through how a Tangle application actually works out. Okay. I think Daniel did a amazing job at covering the basics of IOTA Tangles. So just to reiterate, IOTA is a cryptocurrency, and Tangle is the network on which we would be working on. Is it's based on directed acyclic graph, which is a DAG, as compared to blockchain, which is basically a singular linked list. Uh, so the advantages that you get in IOTA is that there is no miners, so all the transactions go in a feeless fashion, right? So it's free transactions. So that gives rise to a lot of very interesting use cases, especially in machine economy. That's where IOTA stands apart from the rest of the DLTs, where IOTA wants to be and is right now the backbone of IoT, so to say, right? So any machine to machine transactions can be easily it can be easily executed in IOTA. Um, if you're moving from, as I suspect most of you guys are here new to Tangle or IOTA Tangle. So if you're moving from blockchain to Tangle, the above image you might have seen in Daniel's presentation as well. I'll obviously be sharing this presentation on the Blockchain India Talks link, so you guys can follow through post this. But if you're moving from blockchain to Tangle, as compared, Tangle is highly scalable. It requires low resources. That's the one key thing that you need in IoT, right? Because we don't have much space or memory in any IoT device. So we need to optimize all the network transactions as much as possible, right? So the protocol allows you to develop something for as small application or as smaller tool as your Fitbit watch. So it should be that small, and should have that smaller footprint for you to actually run the entire network. It's obviously zero fee, so you can pass data in terms of in simple transactions as well, and we will also see how that is done. It's optimal. Its quantum robustness is amazing because they have you should definitely read the IOTA white paper in which they have explained on how the quantum robustness works. So we won't be going into that. So if you want, I have mentioned in the credits and resources links to read more on that. So I'll be covering a little bit about the consensus and how the consensus in Tangle works. So in one line, it's a bit of non deterministic or probabilistic consensus. So what's the difference is that let's say we all are here and we all have to agree on something, right? That's what consensus is. That if we all agree on something, that it goes forward. So let's say if I show you guys this pen and ask you and ask all of you, like, is this a pen? So we might get mixed responses. So you might ask a few questions. You have your own checklist that, okay, can you write with this thing? I say, yeah, you can write with this thing. Can you I don't know, hold it? Is it a physical object? And so on, right? Just a couple of simple questions. And based on that, you can say that, okay, yeah, yes, this is a pen. And or some of you might have different set of criteria, like can you turn it on or turn it off, and so on, like and so on, right? And based on which you will say that, okay, is this a pen or is it not a pen? So that's a yes and no answer. It's a binary answer. We take all the yeses and the nos, and we get a consensus on, yes, this is this thing, and we come to a conclusion of this is a pen or not. But in case of a probabilistic approach, we take, like, if I have, let's say, each of us will have a set of criterias, and in that I can say that, okay, I am 80%. I'm 80% sure that this is a pen, but 20% I'm not sure that this is a pen, right? So for each of the person, so my 80% of, let's say, my answer, so 80% of, let's say, Ani goes into the yes column, and 20% goes into the no column. And similarly, we take an account for everybody, and that's where we come across in a non-deterministic or probabilistic approach, right? So the advantages of this, like, okay, why don't we use this in a blockchain? Because we don't need this in a blockchain. Why? Because it's a singular linked list. We just need a yes and no answer. Like, okay, if whoever amongst us answers this fastest gets into the blockchain node. But in Tangle, it's not like that, right? It's a graph. Like in the previous one that we saw, it's a graph. So I can get attached to my transaction can get attached to any of these last tips, right? And based on the subsequent transactions that happens, that particular transaction has more likeness to be accepted into the Tangle chain, right? And that's where the probabilistic thing comes into play, where every transactions will go through. The consensus is basically, if I get attached to this particular tip, what are my chances of getting into the main Tangle chain, let's say after 10 transactions, or after 100 transactions, after 1,000,000 transactions, right? So it might so happen that after 10 transactions, your chain in the tip is the longest, but let's say a lot of transactions comes in and gets attached to some other tip, and so your chances actually gets diminished. So that's where it comes around into a probabilistic approach, and this works very well for Tangle. But with this also comes a few more issues. What are these? So let's say the case of double spending, exactly, right? So if I paid 10 rupees to, let's say, Manav or Daniel, 10 iotas in this case, and two tips, and the transaction got attached to two different tips. Somehow I clicked on the send button twice or whatever, or when I sent the node or the library did a mistake and it got attached to two different tips. Now this thing will not be identified until a very later point, when other transactions keep on adding and the chain gets longer, right? So in this case, the probability approach is also not enough. So at that point, the Cordicide, which is the which handles the coordinate things and stuff, will comes up with two other consensus protocols. One of which is called probabilistic fast consensus, which is the FPC, and the second is cellular consensus, which is CC in this case. I'm not going to go very deep into these things, but these are what's responsible for you for a transaction to get attached to the Tangle. How do they do that? They do that by attaching, let's say, some amount of randomness or noise, and then a little bit of weight into each of the transactions. If you want to read more, there's a very good paper written by Sergey and William, which explains like the FPC in detail. So if you like getting into details, this is probably one of the best papers best things to read across. And also do read the Cordicide white paper. So I'll be sharing this slide obviously later on, so you'll be getting the links to read. Right. So this is how the consistent tangle works. If you have any specific questions, we'll take that at the end, obviously. So now that we know like how the consensus works, how do you connect to a tangle, right? So I think Daniel already mentioned like about IRIs and so on. So initially there was only IRI, which is obviously written in Java. So each transactions will get go through a Java virtual machine, and it will be connected. Now IRI can now you can host an IRI node anywhere. It's pretty lightweight. I tried hosting it in Google Cloud and AWS. It works very well. Um, they introduced something called snapshot. So after a while, the IRI nodes makes a snapshot of the entire transaction, and then it keeps and then like the and until and then again it starts adding to these things. So IRI nodes can validate transactions. It will store all the transactions that we send, but it cannot be. But IRI nodes cannot sign or create transactions. So we will have to use some libraries like client libraries. There are lots of client libraries in Java, in C, Python, Node.js, and so on, which you can use with your preferred programming language, and you can connect with the and you can connect with an IRI node. Now, in an IRI node, you obviously have to find your neighbors, and you have to connect with your neighbors, right? So an optimal amount, like at least connect to minimum 5 to 8 neighbors to be on the safe side, and try to connect with a wide variety of neighbors in terms of geographically. So you're safe from that side. But IRI nodes doesn't store all the transactions, because obviously if they store all the transactions like blockchain, it will become huge, and obviously the size will keep on increasing. So what the IRI Foundation came up with is called permanodes, which is a Chronicle project. So Chronicle will store all the transactions, regardless of it was regardless of it is in the current snapshot or previous, like all the history is there. You can obviously run a Chronicle, but it requires a lot of server space and all. So if you have the infrastructure, you can obviously run a Chronicle. It uses something called ScyllaDB, which is a really fast database. Similar to columns and rows, works on table based. It is really high throughput and very low latency. So it's pretty fast as far as the cloud databases go. It's optimized. It's optimal for big data storing. So that's why Chronicle is using ScyllaDB. The next project is Gossamer. It's still prototype stage, but some advantages that it has over the typical nodes is that you don't have to find neighbors. In this case, it has auto peering technology involved. So it will find 4 neighbors, and it will connect, and also it will be open to accepting more connections from the other nodes that's out there, right? And the second thing is it has node identities. So every node will have a particular identity, and it can be so it will have a public and private key, obviously, to identify that particular node. Why is it needed? Is because they have something called Mana, which is like a reputation system on Tangle. So if your node is performing really well, or you are a good node, so to say, so you'll be obviously rewarded with a lot of Mana, and which is a reputation, and your node ranking will be altered. It's still in prototype, but obviously do check out the project on IOTA Tokens GitHub account. You can try setting it up, play around with it, and figure out what to do with it next. In as advanced to IRI, something they're right now working on is Hornet, which is a very light node which is written in Go. So it doesn't have to it doesn't have to support any Java virtual machine. So the performance obviously shoots up way higher. So and also it's extremely lightweight. So wherever, like IRI was already lightweight, but this is even more lightweight. So you can easily run this on your Raspberry Pi and so on. So I have tried it. I've tried running it on Raspberry Pi. It works superbly well. Mine is a Raspberry Pi 2, which was like 2 GB 2 GB space and all. But I mean, now there's even more capacity available. So feel free to play around. Um, the rest, like it's the like, obviously you can't still sign transactions in here. You still need the client libraries to sign your transactions and then send it to the Hornet nodes. And if you're developing, you can obviously go with a private Tangle. So the private Tangle is just your own set of nodes, or one single node even. But you can, but if you're just playing around in your own private setup, so you can just try that out. And it also works well. So the project is called Compass. It's also available like on the IOTA Tokens GitHub network, GitHub org. So do check out the project Compass. So now, if we talk about an architecture of how a Tangle app architecture will look, so this is the entire Tangle network, right? And this will be the IRI node that you will be connecting to. So you can either host your own IRI node and connect, with peers, or Hornet in this, or if you're running Hornet. So I'll just go with IRI because I'm more used to IRI. So you can connect with your own IRI node, and the IRI node will be connecting with other neighbors, which will throw up the transaction to the other nodes, which again will be eventually adjusted in the entire architecture, right? In the entire IOTA network. Your application will be lying in here, where you will be integrating all the libraries, like whichever language you have written it in. And let's say if you have some IoT devices, so your IoT devices will talk to your application or your server data from that side. So this is a broad level architecture of how your app will be connected. If you want to go into depth, so let's say layer wise. So at the very bottom is the IOTA network. Is a pool of all the IOTA nodes will be there. You can have a storage layer where you store like your actual data, and then you send off, let's say, a hash of that, or a proof of that data, of existence of that data onto the Tangle. You can have like some API layers or an Oracle setup in between. If you're trying to integrate Cubic, which will support smart contracts on IOTA Tangle, so you can obviously you can obviously connect with that, and that again will be connected with. And so this is a broad level. This is a layer-wise architecture of how each of your IOTA app can be settled across. Obviously, this is nothing is written on stone. So you can obviously build up your own architecture, simplify this thing as much as possible. If you're just working on a simple application, let's say one IoT device, and that connects directly with the Tangle network, so you obviously don't need all these layers, right? But it's preferable that you have a cache layer and an interface layer and an API control layer and all these layers, so that your app is more secure and can be scaled more easily, right? What else do you need? You need libraries, obviously. Like we were talking about libraries, which will actually sign and create the transactions, right? So there are a lot of libraries available from JavaScript, Python, Golang, C, Java, and so on. There's some C++ and Rust libraries also available, developed by other community members, which might get added by the IF later on down the line. I'm more comfortable in Python and JavaScript, so I have tried these two, and they are pretty stable. I've used it. I have deployed apps on it, so you can definitely go with either of them. We'll just do a small example of how how the functions in particular work with the Python library, right? So the Python library is called Pyota. You can obviously install it with. So yeah, before this, you'll have your virtual environment set up and everything on your own system. Similar to this, if you're going with, let's say, the JavaScript library, so you can just go with the iota.js project, and you will be able to integrate it. So the JavaScript libraries you'll have to integrate via npm or yarn or something, whichever package manager you prefer. We'll just do it with pip here, which is the PyPy is Python's package manager. So once you install this, and you have to initiate it. Now this link that I have written in here, this is the IRI node link. If you're hosting your own IOTA node, so you can so you'll be able to, so you can replace this link with your own with your own IRI adapter link, which is the URI of it, and your node will connect with it, right? So that's it. Like that's as simple as to that as to connect with. So they have everything written in the functions there. Now let's say if you want to send a transaction, right, on the IOTA. So yeah, okay. A very important security thing is that don't use any online methods to generate seed, or even if you have to use, go with something that the IOTA Foundation supports, like the Trinity wallet. So it's very important that you safeguard your seed and nobody else stores your seed something on their own database or something, because this happened this happened in the past, that a lot of people were careless of where they're generating the seeds, and their wallet was subjected to exposure. So you have to be very careful how you generate your seed. Obviously, it goes without saying you wouldn't be generating your password in an online by an online account, right? Like you'll be writing something of your, so you can generate a seed. They have a function to generate the seed. Um, once you do that and you initiate this API, this API parameter, so you can now send all these things. So the address, right? So every address, so you can generate an address from the seed itself, and it's advisable that you use one address only once to send a transaction. You can obviously receive any number of any number of amount on your address, but if you're sending a value, then just send using one address and then move on to generate a new address for a new transaction. It's just a safety tip. You can choose to use the same address all the time. It's up to you. Value is how much IOTAs are you trying to send. Tag and message is optional. So if you want to send some data along with your transaction, you can add it in message. Tag is basically what you put into, like it's only should be identifiable by you. So let's say you have multiple applications, you can name your tag however way you want. They have a function which will encode the tag in a certain format. So it remains constant for all the transactions and so on. So and that's it. This is the only function that you need to send your money across. Send your IOTAs to somebody else. Feel free to try it out on your systems if you have it available right now, or maybe later on. It's also beautifully written in the documentation, so you won't be missing out on anything. Now, what happens really when you send a transaction, right? So when you send a transaction, at first the transaction is getting created by your library itself, what you're using. So in this case, the IOTA library will be creating the transaction. It will then it will create, like, if you have, let's say, multiple transactions, so it will bundle it into one, and then it will find a tip. There is a tip selection algorithm, which I think you should definitely read more in detail. Once it finds so it does a little bit of proof of work, like I think Daniel covered that part. Once it finds a tip, and it does and it can connect to that and it can connect to that tip. So then you'll have to verify two more transactions, the follow-up transactions, to be able to actually connect to that particular tip, right? And once you're connected, and that's it, you're done with that. And then somebody else will obviously the next transaction will again verify two more transactions, and so on. The flow will keep on going. So this is basically more or less how. So this basically more or less how a transaction will work. Now, let's say now we saw like how to send a transfer, right? And because it's free, yeah.
Aniruddha, I'm just saying that let's take some questions at this stage. So if people,
Yeah, I'm just like almost done with this. So I have one more slide, and then we can go through some use cases and then take all the questions together. All right. So okay. So this is how like all the transactions work. But now since it doesn't charge any fee, it's very easy to store data on a Tangle. Just to store data if you want to store data. It's not advisable to store a lot of data because then you don't want to do that. Doesn't make that doesn't really make sense. But if you want to store data, just turn the value to zero. It's the same function as before. Just the value is zero, and put up your message there. It will convert into a tried string. Okay, what is a tried string? Do go across and read it. Read more on it. It basically converts your string in a particular format. And this is, you can store your data like this, right? So that's all you need. That's all you need from and there are some more functions available in the traditional library, check balance and then you can view all the live transactions as well. So if you want to build an IoT Explorer, do some visualization on top of it, that's also easily can be done with just the library. You don't need anything else. There are some public nodes available which you can connect to. So if you're not running a node or you just want to try it out, you can just connect to one of the public nodes. Just go to one of the websites. I'll share the links later. Right. So let's go through like a couple of use cases and then we can go back to taking questions. So let's go through a smart charging use case. So since it's feeless and it can work on a machine economy basis, it gets very simplified if you want to. So there's Eladil has actually power station where you can just go, and if you have an electric vehicle, you can just pay in IOTA and get it charged. So you can also write conditions that let's say how much is the rate, right? Let's say for 10 IOTAs you get a minute of this or something, fuel or gas or something, right? So you can just pay that much amount and that much charge will for that much time your vehicle will be charged, and then you're going to move along. Some of the other things that you can do is you can go in the repair shop or insurance even. And all of these things you can pay via IOTA. Now let's look at like energy grid use case. So this is a general architecture that you will see for an energy grid. So in here it's depicted with MAM, but now there's this new project that's Streams. Like I think Daniel was also mentioning that. So instead of MAM, it will be Streams. But since this is an old architecture diagram, so it just has MAM in it. So ideally, like you can have any sort of energy in the and you can transfer it to the producer. Will have let's say your particular integration with the libraries and everything, and it will collect data from your devices, which is your solar device or your wind device, geothermal device, and so on. And your transaction will happen at this level, at the producer level, which will pass on the data to the grid. The grid will be basically the entire network, or excuse me, a representation of the network in a way. And then there'll be other consumers who can actually pay for that and get it. The similar function as a car charging works, the similar can be extended across to the entire energy grid sector, so as to build up an entire smart energy thing. So the advantages is that one, it's feeless, right? Second, is that it can actually scale really well, and it's been also tested across. I'm not sure if it's live anywhere, but it's been tested across into multiple pilots. So you can definitely check out like the articles at the IOTA blog, IF blog. They have really good mention of the entire infrastructure. Um, Now let's look at another use case: data and asset marketplace. Now because IOTA has a data marketplace. By the way, you can just go to data.iota.org and you can look at the entire marketplace in there. So the idea is to have a common platform where the asset providers and the service providers, they can buy and sell data as easy as possible, right? Um, can be that's if you have any questions, let's take it. Hello? Hello? Am I audible? Okay.
Can you all hear me, guys? Can you just
Can
confirm
you
by
hear me?
writing on the chat if you guys can hear me? Perfect.
Okay,
I think that there was some
just
network issue even.
so yeah, I think this is issue time with my internet. It's getting disconnected. I guess says it's unstable.
Yes.
Okay, so all right. Yeah, pretty much. I'm not sure where if you guys
Sure.
go to that thing. But
Anirudh, we still have some disturbance at your
okay,
end.
I guess it's real time. Okay, so let's take some questions and um, okay.
Okay. So let me just take the questions for you guys that you have until the time he doesn't come back. And he's getting his things sorted. So, all right, I think so. He's back now. Yes, Abhay, I think so. Yes, the voice is hacking. I think so. It's a Wi-Fi issue at his end, but that is okay. We can still answer the questions that are there, or else what we can do is we can go on to the next session, and we can have him again later, and he can answer those questions. All right, so I'll be starting with the next session then.